Okay, lesson 3, central angles and arcs. I hope you enjoyed your day off on Friday and got caught up on some of the on lesson 1 and 2 and got your tests done and everything. This chapter on circles is a pretty important chapter, even though it's at the end of our time. So I want to make sure that you go through and learn all the definitions and theorems in this chapter. As you saw in the SAT, there are circles on there, and the more that you understand how the parts of the circle work together, the easier those problems will be. In lesson 1, the main theorem that we learned was if a line through the center of a circle is perpendicular to the chord, it bisects the chord. And then it goes the other way around. So keep that one in mind. And the one in lesson 2 that you have to keep in mind is if a line is tangent to a circle, it is perpendicular to the radius drawn to the point of contact. Or theorem 69, if a line is perpendicular to a radius at its outer endpoint, then it is tangent to the circle. So those are the main things that we learned so far in lessons 1 and 2. We're going to learn a lot more in lesson 3, and this chapter is loaded with material. So try to keep up with all the work and understand all the problems. I need you to do all of the problems, not just the odd, and you can do the odd. You can do the odd only proofs. So let's just start here. We have two circles. Right here we have our two circles, one with a horizon going through. They just call this line the horizon. In the first circle, the horizon is going right through the center, and so it divides the circle into two semicircles. So this is a semicircle, which is 180 degrees, and then this would be a semicircle, which is also 180 degrees. This one, it divides it above the center, so it splits it into a minor arc, which is the smaller arc, obviously, and then what is left is called the major arc. So a chord can separate a circle into a smaller minor arc and a larger major arc. Another thing you have to know is what a central angle is. If we look over here to this circle with all this stuff written all over it, this angle, AOB, is called a central angle because it's the angle in a circle whose vertex is the center. Later we're going to do things called inscribed angles where the vertex is on the circle. But just think central angle, vertex is in the center. This central angle is 120 degrees, and the arc that it intercepts is also going to be 120 degrees. Let's look at a couple definitions. The degree measure of a minor arc, and we talked about the minor arc, is the measure of the central angle. So whatever the central angle is, that's what the minor arc is. Not the major arc, but the minor arc. A semicircle is, we talked about up here, it's half of the circle. A circle's 360 degrees, so a semicircle will be 180 degrees. A major arc is the whole circle, 360 degrees, minus the measure of the corresponding central angle. So it would be 360 minus 120, so the major arc is going to be 240. And then a circle is 360 degrees. Here's our first postulate for this lesson. Postulate 13 is the arc addition postulate. It says if C is on AB, then the measure of, here's C, right here. If C is on the arc, and they do arcs by putting this little arc thing above it. If C is on arc AB, then we can add the two arcs together. A arc AC plus arc CB equals the measure of arc ACB. And arcs with equal degree measures are equal arcs. So that's pretty much common sense. Just like line segments, we can add parts of the line segment to the whole line segment. We do have two theorems in this lesson. The first theorem says if two chords of a circle are equal, their minor arcs are equal. So over here, look at this drawing. If we have, this is a chord, AB, and we have chord CB, and we have marked that they're equal. If they're equal, then the minor arcs, they intersect and form minor arcs, then the minor arcs are equal. So AB is equal to CD. And then 71 is just the opposite. If the minor arcs are equal, then the chords AB is going to equal CD. So I don't think anything's too hard. It's just the problem is you're just going to get a lot of information. It's going to be hard to remember it. We're going to look at problems 11 through 14, and then I'm going to do a proof, and then we'll be done with it. They give you in 11 to 14 this drawing. They tell us that angle RDA, the measure of RDA is 100, and the measure of RDN is 145. You're going to find this is really easy. They want you to find the measure of ADN, which is this one. So you know that all of these angles, if it's in a circle, they have to add up to 360 degrees. So I'm just going to take 360 and I'm going to subtract from it 100. And I'm going to subtract from it 145. And we get 115. So we get the measure of angle ABN is 115 degrees. Easy enough, right? Hopefully that will add it up. 12. We want to find the measure of AR, arc AR, and the measure of arc RN. Well, remember, whatever the central angle is, so is the intercepted arc. So this one, RA, would be 100, and our arc RN, the measure of arc RN, would be 145. And now we want the measure of arc ARN. ARN. So this is that postulate, the arc addition postulate. So you would add the measure of arc AR plus the measure of arc RN, and you would get the measure of those two arcs is 245 degrees. And then finally, we want the measure of arc ANR. ANR. And we found out that this is 115, so we know this is going to be 115. The intercepted arc is 115. So we would just add 115 plus 145, and we would get it's 260. And they get a little bit harder. There's later on in section 1, there's one problem that looks a little bit tricky. Section 2 is all proofs. So you're going to be doing proofs 29, 31, and 33. I think if you look at the answers, it's going to be self-explanatory, but I'm going to do one proof for you. So hold on while I find that proof. Okay. Here we go. This is number 32. It gives you this picture right here, and it says given in a circle R, in circle R is the center, AI, here's AI, is perpendicular to DN. So I'm going to try to write this all in. So I'm going to do my best to get this done here for you. So, let me get the right color. Okay. So I'm going to write the given OR, in circle R. I didn't even read my writing. Circle R, we're given that. We're given AI is perpendicular to DN. So then we can say angle AI, I can't read my writing, D, and angle AIN are right angles. And the reason is perpendicular lines form right angles. Okay, then we can say angle AID is equal to angle AIN, and the reason for that is right angles are equal. moving. So now we have this angle is equal to this angle. Let's look to see what we're trying to prove so we know where we're going. We know we're trying to prove the measure of CA, arc CA, this one, is equal to the measure of NA. So what I'm going to try to do is I'm going to prove these two triangles are congruent. And what we don't know, let me put it in green. Then I'm going to prove these two triangles are congruent. And then I'm going to say these two parts are equal by CP, and then I'm going to be able to say that these arcs are equal. So first I'm going to try to get the triangles congruent. And we can do that. We can also say that AI, oops, wrong color. We can say AI is equal to AI, and that's reflexive. And so we got this equal to this. We're getting somewhere. We still need to get one more part. We have side, angle, and we're going to try to get these parts right here equal. And I can say that DI is equal to IN. Let me see if I can get the wording of that right. That was from the first lesson. And the first lesson, the theorem says, if a line through the center of the circle is perpendicular to a chord, it bisects the chord. So really, I should say that AI bisects DN. And I'm just going to put in here the theorem number, theorem 65. You would write this out in some sort of words. Now I can say DI equals IN. And that reason for that is if a segment is bisected, its parts are equal. I'm not going to write that out either. So now we have the side angle side, so we can say triangle AID is equal to triangle AIN, and our reason for that is side angle side. And then I can say DA is equal to AN. Have these two triangles are equal, side angle side. DA equals AN, and that would be CP. And finally, I can say AD, arc AD, is equal to, and they actually put the measure of arc AN. I have it backwards, but it's the same thing. And the reason that we can say that is because of theorem 70. It says if two chords of a circle are equal, then their minor arcs are equal. So this is theorem 70. And you would write something like if two chords of a circle equal, then their minor arcs are equal. Some version of that. So you can see how these proofs work. This was a longer one. I picked one of the longer ones to do. I think if you look at the answer book, you'll be able to see where they're going on these. But I want you to try to do the proofs without looking at the answers first, of course. All right, that's it for lesson 3. I hope that was helpful.